Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to actually talk about how we can use our calculator to help us get decimal answers to different log expressions. So we're going to study some applications of logs here in a little bit, and a lot of times I don't want you using your calculators to get an answer, but when it comes to like an application problem, like at the end, it'll be good to know like if it's a problem about the percentage of something that's left or whatever, you're going to need that decimal. So that's the main goal. But to start off, I just want to do just another log inequality, okay? And my arrows, I realize, are kind of off. This blue one is here. And then this thing is right here, okay? So the red arrow is the green curve, and the blue arrow is the black one here. So I want you to kind of see, so let's just talk about it from the picture, I guess, first. So the answer to this inequality, like if we want to say when is the black one less than the green one, right? We can see there's like a turning point or crossing point is what I want to say right there. And then there is a vertical asymptote for the black graph. And so like the little chunk from right here and then like up to that vertical asymptote right there will be the answer. And so that is where we should be getting less than the green one, and then so that'll be the solution. So now just doing the algebra out to see what those numbers are. So it's a nice one because you have the same log base 2 on both sides, so you can just go and cancel that log base 2. And then you have x squared minus 8x, then must be less than 6 minus 3x. And literally at this point now, it is a chapter for quadratic inequality. And I really hope at this point quadratic inequalities are feeling like really repetitive, because we have done a lot of them in this unit, definitely. So minus 8x plus 3 is going to be minus 5x, minus 6. Same kind of thing as always with these. We're just going to go ahead and get the roots and then graph this thing. And then use the graph to answer the question. So the roots are -1 and 6. So we've got that kind of thing. And then we want to know when this thing is less than 0, right? And so less than 0 is this chunk through here. So it's looking like anything from -1 up to 6 is going to be the answer, but we are not done yet because we have to do the domain, right? So the domain part, you need x squared minus 8x to be greater than 0. So another quadratic inequality. So let's just put that over here. We got roots, of course, of 0 and 8. So we got 0 and we got 8. And then greater than 0, it's basically going to be this chunk and this chunk, right? And so the domain for this one is anything, less than less than 0 or bigger than 8, right? And then we got another domain over here. We got to know when is 6 minus 3x greater than 0. Well, that's just when 6 is bigger than 3x. So when x is less than 2. Okay? So those are all my inequalities. This one, and this one. And so we're basically checking our answer, right, against these domain inequalities here. So one thing you can see, so x bigger than 2 up here, x has to be bigger than 2, but here we're saying x need to be bigger than 8, right? And so you always need to take the more restrictive thing. And so if you're bigger than 8, you're going to be bigger than 2. So that part actually is not needed. That's not going to help us, right? So that kind of helps to reduce the problem now to just this chunk and this chunk. Bigger than 8 doesn't make sense because anything bigger than 8 is not even in the solution space, right? So that part you can chuck out. Now you're down to, whoops, I did not mean to draw on that. So now you're down to this, x less than 0, okay? And then this region here. And so you basically just blend those together, right? The final answer would be anything where x is less than 0 or bigger than -1. That'd be it. So, yeah, and that really is that region. This is the y-axis. So anything less than that, right, works. And then bigger than -1 will also work. All right. So this is how we can go about using our calculator to basically evaluate logs, okay? There's 2 ways, actually, that we can do this. And it may be easier to show you some of this in person and on like an actual calculator, and I can't show my emulator software here and talk about it at the same time. So I'm going to opt for the talking about it. But there's basically 2 ways that you do this. There's an easy way on newer calculators, and then there's a little less easy way, but still pretty easy. So the older way, and this is the way a lot of you on older calculators will do it, all old calculators have log x. Like they'll have log base, there's 10, right? That's the common log. All of you have a common log button. So if you have log base a of n, there is, and I'm not going to prove this to you why this works, but I mean, if you want to know, I'm happy to show you. But basically, you can evaluate log base a of n with base 10 by just doing log of that n, the top thing, over log of a. So that is truly base 10 log of n, base 10 log of a, okay? So this base a has changed to a base 10. That's why we call this thing the change of base formula. So that is how you can do it on old calculators and new calculators too. But if you have a newer calculator, then like this is like TI, a lot of the newer TI 84s and up basically, you just go to the math like button on your calculator, and if you scroll to the bottom, you're going to see this thing that says log, and then literally it's in caps like that. And what it's going to do is it's going to pop up on your home screen when you hit enter. It's going to pop up something like this. And it's fairly self-explanatory because it's basically just saying, what do you want to put in these 2 boxes here? In this box, you just put like the base, like if the base was 3 or something. And then here, if you're like want to input, I don't know, 7, okay? You can just put log base 3 of 7 in like that. And if you do that, you hit enter, you're going to get something, well, I should use. So logs are irrational, so they're going to go on forever and ever and ever, but log base 3 of 7 is about 1.77, okay? So that is how you can evaluate logs on a calculator. You either do it in a division step like this with a common log, or you literally have a button that just does like base 3 and stuff. So I want to revisit one of these problems, but this time do it with decimals. So before I was saying write the answer in exact form, which is actually still better, but there will be application problems coming up pretty soon, and you'll want to know how to do it with a decimal also. So these are the problems you can use either, so like right away, you can either use log base 3 to cancel this side or log base 7 to cancel this. So so you can either use log base 3 and solve this problem or log base 7 to get yourself started. So let's just do log base 3. All right, so if we do log base 3 of both sides, Cancel that, right? And we get 5 to the y is less than log base 3 of 7. Oh, sorry. Y minus 2. And then this is where I'm going to use log properties. So this thing, right, can move in front of the log. And so we could write that as 5y is less than y minus 2 times log base 3 of 7. And before I was like, let's just leave that the way it was and like, just distribute it in and combine like terms and whatnot. But now, just for good practice with decimals, we will just get that 1.77. And when I'm doing a problem like this, what I do is I would use my calculator, and this goes on and on forever, right? So this is like keeps going. So I don't really put 1.77 in here. What I do is I highlight on my calculator this. So if you don't put in the approximation, you're going to get a much better answer, right? You're going to have less of a rounding error. If you put in 1.77, you might get something a little different than what I'm about to kind of put down here. So anyways, basically try to keep that on your calculator and just like multiply by -2 and so on. So, but when I'm writing the answers down, when I'm writing my work down, I would put in 1.77, even though it's not really 1.77. I would also put in that because that is roughly what that number times -2 is. So then I'm just going to minus this over. I would roughly get 3.229y is less than minus 3.54. And then go ahead and divide by that 3.2-ish number. And you get something that y is approximately less than negative 1.097. So that is basically how you can go ahead and do these things on your calculator if you want to do that. And just know that like if you go work in like the professional world and the STEM careers, like you don't want to be rounding like this as you're going through long calculations. You're going to get a lot of things wrong because of that. But there is some stuff coming up here soon. If you remember those problems on like day 1, I showed some applications of logs and exponentials. That's what's coming up here really soon. So those problems, we really do need decimals. And so it's good to know how to find those. So just for extra practice with properties of logs, I just wanted to do basically this one other example where in this problem, I want to expand that thing out as much as possible. And then this one, I want to condense it as much as possible. So this first one, if I was expanding it, you have a power, right? Because you have a root, a 1/2, right? And so we know that based on properties of logs, we can do this thing where we take the power p here and we can move it in front. So we can write this as 1/2 times log base 2 of 7x cubed times y. And then I have multiplication in here, right? So I can split this up into addition. And so I can write this as 1/2 times log base 2 of 7 plus log base 2 of x cubed, plus log base 2 of y. And then, that would basically be as expanded as possible. You could distribute this 1/2 in. If you wanted to, you could move this 3 in front, but that doesn't expand it anymore. So 3 terms would basically be as expanded as you could get here. So this kind of thing is purely just to practice, properties of logs. It's not really something that we would ever want to do. I can't think of a time where we'd want to take this and write this instead. This is more complicated, right, than this. We typically simplify things. So we typically go from stuff like this to this, kind of like this problem. So you might run into that in an equation someday, and you want to simplify it. So, basically we're just going to use these three things to help consolidate this into one log, okay? So the first thing I might do is I might move this power up here. And that's nice because if I do that, now what I have is one log minus another, right? And then at that point, we can use this middle property, it's like quotient property, right? And we would be able to consolidate it into log base 7, 81y to the 12th, all of that square rooted over 3, okay? And so that does it. That turns this thing into one log. There's obviously some stuff in here you could do if you wanted to. It didn't ask you to do this, but it's just good practice. Square root of 81 is 9. Square root of y to the 12th is y to the 6. You don't need absolute value because 6 is an even power, so it'll stay positive. If you want to put it in, you can put it in, but you don't need it. And then we got a 3. So I guess you can go even a little more. You could do log base 7. 9 divided by 3 is 3. And then y to the 6. Maybe we'll just stick absolute value around the whole thing for good measure. But yeah, so, this right here, everyone that I know would argue that that is much simpler than that thing, right? So this is typically how you use log properties. You kind of take these messy things like this and you simplify it down to something like that.